Hi guys, this is Mrs. D. This is lesson 7.5. You should have your journals open and ready to take notes the same as you would as if we were in the classroom right now. If you do not have those at hand, pause the video and get them ready and come back. Alright, so the first thing that we are going to talk about are radicals. When we've been dealing with things that have rational exponents. For example, we know that 4 to the 1/2 power is the same thing as the square root of 4 to the 1st power. So we've been using these, but we haven't really talked about what they are. And this is our official notation for this that we're going to talk about. Okay? So this whole thing together is called a radical. The end part right here, that's called the index. So up on the example that I gave you, the index would be 2. Alright, the radicand is this guy right here. So in the example that I gave you above, the radicand would be 4. And this right here is the radical symbol. Sorry, the arrow is not the best. Let's try this a different way. This is the radical symbol, or the radical sign. Alright, and then this one up in this first example I gave you is just an exponent, so we don't really talk about that when we're talking about the radical. Alright, so go to problem 1. Problem 1 asks us for the third root of 125. All that's asking us is what times itself 3 times is 125. Another way that we could look at 125 is 5 times 5 times 5. And since we can see that there are 3 of these in here, and there's a 3 out here, we know our answer is going to be 5. All this is saying is 5 times itself 3 times is 125. And that's what the problem was asking us for. The original problem right here is asking us what times itself 3 times is 125. And the answer for that is 5. Alright, problem B, or problem 1B, asks us for the fourth root of 16. So that's asking us what times itself 4 times is 16. It's not asking us what 16 divided by 4 is. It's asking us what times itself 4 times is 16. So something times itself 4 times. Since 16 isn't the biggest number, I want to start small and ask myself, would 2 work? If 2 wouldn't work, then I would try 3 and so on. But it just so happens that 2 works. So our answer is 2. Go ahead and pause the video and try the got it's for problem 1. Then come back and check your answer. Alright, for the third root of 27, you should have gotten 3, because 3 times 3 is 9, times 3 is 27. For B, you should have gotten 2, because 2 times 2 times 2 times 2 times 2 is 32. So 2 times itself 5 times is 32, and that's what the problem's asking us for, is what times itself 5 times is 32. For C, you should have gotten 4, and D, you should have gotten 6. If you did not get those, check back at the original problems we did. Just rewind the tape and rewatch it. If you still don't understand, make sure to ask me about this in class tomorrow. go ahead and note this key concept. We have talked about this in class before, and this is going from exponential form to radical form. And notice the denominator and the numerator happen alphabetically. And I don't mean the M and the N. I mean denominator comes first, numerator comes second in both of these forms. Denominator, numerator. Problem 2 wants me to write this from exponential form into radical form. Now, be careful with this one. Notice it's just the a that's going to the 2/3 power. The 12 is actually to the first power. We just don't see that because we don't have to show when something's to the first power. So the 12 is going to stay right outside. The a will go inside. And then we just need to think about where the 3 and the 2 go. And we know denominator, then numerator. And that's it. All right, for B, it's a little bit more tricky because we actually have this whole thing inside going to the 4/5 power. So that's the same thing as 64 to the 4/5 times a to the 4/5, which we've learned in properties before. An easier way to think about 64 to the 4/5 is to look at it written in radical form and to think about, is there anything that's a perfect fifth root that is a factor of 64? And we know that 2 to the 5th is 32, and 32 is a factor of 64. So this is the same thing as 32 times 2, and then that whole thing will go to the 4th power. So since we know that the fifth root of 32 and then we could say the fifth root of 2, right? We know the fifth root of 32 is 2, so that 2 can come out. It's going to be going to the 4th power, and then the other 2 is going to stay there. And then our a, I have forgotten about the a. Let's bring him down. We don't want to forget him. There we go. And then we can go ahead and simplify. And 2 to the 4th is 16. And then we could put everything else inside one radical. And there you go. Go ahead and try the got it's and come back and check. Alright, for got it 2, a, you should have gotten the 6th root of a to the 5th. B is 5 times the 3rd root of x. C is 9 times the cube root of 4y squared. If you had any trouble with those, go back and look at the books example, rewatch the video so far, and if you're still stuck, make sure to ask me questions when you come to class tomorrow. Alright, for problem 3, it wants us to go from radical form to exponential form. So we'll be doing just what we were doing before, but backwards, or the opposite. So on problem A, we know our radicand is b, so we know we're going to have b to some power. And then we just have to remember from our key point before where the 3 and the 5 go. And I know the denominator comes first, so that's the 5, and numerator comes second, so that's the 3. And that's it. b to the 3/5 is your answer for that one. This next one's a little bit trickier. What we don't see here is that this whole thing is to the first power, because we don't have to show when something's to the first power. But it's helpful to note that, otherwise we might be tempted to make the whole thing to the 5th power when actually only the d is. Alright, so let's go ahead and write 27d to the 5th, which is our radicand, to the 1/3 power. And we learned in a previous lesson this is the same thing as 27 to the 1/3 times d to the 5/3, because we multiply our powers, and 5 times 1/3 is 5/3. We also know that 27 to the 1/3 power is 3, because 3 times 3 times 3. And so we end up with 3d to the 5. Oops, let me write that a little neater. I'm sorry, I'm writing with a stylus. It's not the easiest thing. Oop. 3d to the 5/3 power. Alright, pause the video and go ahead and try the got it's for problem 3. Alright, for A you should have gotten s to the 2/3, B is 12x to the 4/3, C is 32y to the 5/2, and D is 4a squared. Alright, we're not going to panic over problem 4 being a word problem because they've given us a formula. Pause the video and read the problem, then come back ready to label our variables. Alright, you should have noted that R is for rate and M is for mass in kilograms. And we're looking for the metabolic rate of the dog with a body mass of 18 kilograms. So we're looking for rate, so the R is not going to change. Remember, with the formula, we keep things the same. We just plug in the things we know, right? And we actually happen to know the mass is 18. Alright, from here, you're actually allowed to use your calculator to to estimate. So the way to do that is you're going to do 73.3 times, and then you're going to do 18. In the parentheses, you're going to use 3/4 as your power. And then when you hit enter, you'll get a big long decimal that we're going to round to the nearest calorie. So 641 calories per day. Make sure that you label that. Sorry, my handwriting is not the best with the stylus. I'm getting better. Alright, pause the video and do got it 4. For got it 4, you should have gotten about 1,868 calories per day. In your journal, go ahead and try lesson check problems 1 through 7. Make sure to rewind the video as needed and read your book as needed. Tomorrow in class, be prepared to help those who need help, and also be prepared to let me know where you might be stuck so that we can clarify and get everybody on the right track for the in-class assignment that we will be doing together.